The electric inspection should start on the exterior of the building. Per the ComStop, we are supposed to identify the main electric installation. In this particular case, well, in any case, there's only two ways you can distribute electric to a building: overhead and underground. If it's overhead, it has to have a specific height requirement based on where it's traveling above what device, whether it's above the grade, whether it's above a street, whether it's above an alley, whether it's above a wide street. But if it's underground, it comes into a meter bank. From the meter bank, it comes through, gets metered and gets measured, and then goes into the building. Once it goes into the building, it gets distributed out to the main electric service as it goes through the building. But the key out here is to make sure this looks safe, the wires are contained, the wires aren't open, and there's no opportunity for me to come in contact with the wires. Imagine you're out here doing landscape maintenance and you got your weed whacker. You want to hit the conduit, not the wires. This is high voltage electric, and so we want to make sure we're safe. So we want to look at the housing, look at the system, and then from there we can move on and do the interior portion of the electric distribution. As part of the electric inspection outside, we've looked at the main electric service. That's where the meter is. Remember, there are two types of services: overhead and underground. Within that service, we typically need to try to find our main ground and our main bonding source. In this case, I've looked in this room. I cannot locate it in this room. We've looked outside at the meter. I did not locate it at the meter. So then I can only suffice that it is probably a foundation bond ground. So within the meter socket, within the conduit at the meter, it's gone down into the foundation, and that becomes our rod and our ground. But I have not found it anywhere else in the building as we've gone through. It's very important that you attempt to locate that. So on your inspection in this building, I would make a note saying ground and bond not visible. Verify location with owner. It'd be how I'd handle that. Now, this is our main electric room. In a main electric room, we have to have a working space. Working space is different than dedicated space. I want to talk about working space first. With working space, we need to have side to side at least 30 inches. So that means from this panel to that wall, from this edge to that wall, I need to have at least 30 inches, or the width of the panel, whichever is greater. So this is electric, this is electric, this is electric. So if I went from here, this is greater than 30 inches, so then I could be directly against a wall on this side. But if this was less than 30 inches, then my wall on this side couldn't be any closer than that 30 inches. So it's very important that you have that space identified. Our next number that we worry about is 36 inches. With this service that we have, I need 36 inches from front space. That's the space between the front cover and my body. I need to be able to work in 36 inches. So that's 30 inches, that's 36 inches. If this was a larger service, let's say 480, then that distance needs to be increased. And please refer to the table that you have in your literature for those exact numbers, because there'll be some changes. If I've got electric device on this wall and electric device on this wall, then I need to have more working space. If I've got electric device on this wall and a non-grounded wall, then I have to have a different space. So please refer to all the tables. So if I have 30 inches to the side, 36 inches from front to back, then I need 78 inches tall. That's very specific, but I need 78 inches. This is my working space. This is the space in which nothing other than electric can live. If I walk in this room and I see a mop bucket laying here, that's an issue. If I walk in this room and see that they're storing furnace filters here, that's an issue. If I walk in this room and there's merchandise here, that's an issue. This is the electric world. We have to have that. So that height gives me enough height to work on all of this equipment safely. The next words that we use are dedicated space. Dedicated space is the space in which must be only electric. And now that extends all the way up to as high as 6 feet above these pieces of equipment or gear unless I have, like we have here, a fireproof ceiling. But if I didn't have a fireproof ceiling here and this extended all the way up higher, then I need to have nothing not in the electric family to fall in that space. Again, please refer to all of the literature we've provided to have great illustrations of what those dedicated space and working space rules must be. What I love about those rules is they're cut, they're dry, there's no gray. So 30 inches, 36 inches, 78 inches. You work in that world, everything is perfect. Now, we have 3 panels here. Nobody should run up to these panels and get all excited and open them up, because that can be dangerous. The safety is absolutely first and foremost. There's 2 ways to verify that we're going to be able to work in a safe environment. One is using a non-contact voltage sniffer. What I would use on this is I would place this around the electric panel and the door to make sure I don't have any dead charges or stray electricity touching any of this steel that, if I came into contact with, is going to cause me to have an electrocution problem. That's first and foremost. If you don't have a non-contact voltage sniffer, buy one. If it failed, have a backup. But let's just say you don't have either. I'll put that in my pocket. Let's talk about physics. Let's talk about safety real quick, because I think safety is a very key element, and one of the most dangerous things we do during an inspection will be the electric. We have 2 hands. We have a right hand and we have a left hand. If we touched electric and I grab onto it, the stray electricity will go through my muscles and constrict my muscles. So what that will do is it'll cause my fingers to grab, not fall off. So if I had loose electric and I grab it, I won't be able to let go. And so being not able to let go will not only cause a burn, but what could cause an electrocution simultaneously. So that's why we never grab electric without testing it. If I had a heart, that's usually debatable amongst my students, but if I had a heart, it largely lives on the left side of my chest. And so if I was to touch anything with my left hand, it would go through my left hand, through my chest, and out my left foot, because electric wants to move to the easiest path possible. So if I want to avoid a shot to my heart, I only use my right hand. So if you want to be safe and do this without a testing tool, then I usually put my left hand in my pocket, I grab my right hand, and I use the back of my right hand, and I touch it with my knuckles. By touching it with my knuckles, if I had stray electricity, it'll make my hand fly off and slap me in the face. The worst I'm going to come up with is most likely broken glasses, a broken nose, or a slap in my face. But if I grabbed it, I could still end up with that contraction, right? And that's going to cause an electrocution. So if I do this, and if I had stray electricity, it would most likely cause the hair on your knuckles and the hair on your arms to start standing up. Then I would know I don't want to address that panel. Another thing for safety, you look in front of yourself. Is there standing water? Is there anything that I'm going to come in contact with? Again, 30 inches, 36 inches, 78 inches. That's my working space. That's what I need to have to be able to work in here. So in looking at these panels, unless you open them up, you don't know what you're dealing with, because there's no numbering, there's no labeling on what these panels do. So I will come to this first panel, left hand, pocket, right hand, free, finger opens it, and I open this up. If I open this up, now I can see that this is my main. This is my main electric distribution site. This is a secondary panel, and this is a secondary panel. I'm not calling them sub-panels. I'm calling them secondary panels. Now let's talk about the main panel. According to the ComSop, we are required to note the surface disconnect size and overcurve protection. on this particular panel here, that's located on this inside label plate. That label plate is placed on there by the manufacturer. When the manufacturer designs the electric for this building, the panel is sent out specifically designated to be this size. This particular one is 208, 120 volt, 3-phase, 4-wire, 400 amp panel. All else fails, read the instructions. It's written right here for us, and we have that. Now within this panel then allows us to have a disconnect here for this panel, a disconnect here for that panel, a disconnect here for another panel that's in another portion of the building, which we'll have to locate. And then lastly, another disconnect here for the surge suppressor that they've installed on the building for protection. And so our job is to identify this size. There's nothing in the standard that requires us to take this dead front cover off and observe the wiring. In fact, for most inspectors, this type of panel should probably never be opened. The way the cover is assembled, if I take this off, I have to take this small screed off first, then I have to take the door screed off second, then that opens up the sides. Then I can take off this portion of the trough up here and this portion down here off, and I'm still not going to see the wires. I might see a few of the bends, but I'm still never going to see the connections. A commercial panel is not constructed in the same way a residential panel is. These have so many other methods of attachment and methods of protection that we're not able to see. While looking at the main service panel, the first thing I want to identify, are all these conditions sealed? And is there any spot in which a person, a pedestrian, a person of service can walk in and touch the wires? In this case, this was designed to have 2 more spots here for expansion. They're nicely sealed. So in this particular panel, I do not have anything remarkable that I need to alert my clients to other than the size, 208, 120 volt, 3-phase, 4-wire, 400 amp. That's the most important thing that we're going to do right here. Things that go above and beyond the scope of it, of the ComSop, would be an infrared. You could take an infrared and look at the breakers and see if there's any overheating conditions, but that would go exactly beyond the standards as well. With that, we'll move to the next panel. So if we know the main panel here, I'm leaving this open. It's never good practice to leave panels open because of safety. But I'm leaving this main panel open because we're in a confined room. But I want to be able to open this panel. And again, the first thing I'm going to look at on this panel is our size. To being consistent, this is 208, 120, 3-phase, 4-wire. And it's 225 amp. By looking at 225 amp here, this panel does not have a disconnect up here. They don't have a disconnect up here because the disconnect is located in this main service panel. By having that disconnect there, it's within line of sight. That checks the rule, and it's congruent. If I've got 225 amp disconnect here, and this panel's rated at 225 amp, then I know that I'm working in a system that isn't put in incorrectly. What would be incorrect would be if this was rated at 400 amp and that was a 225 amp, then I'm not putting enough power to that so that I could have an issue of communication. I like things being perfect. So if this says 225 and that says 225, I am good. The next thing we look at, according to the ComSop, is we're supposed to note if a panel is labeled or not labeled. Our labeling is usually on the inside of the panel. Our ComSop doesn't say that we have to verify the labels are accurate. I don't even know if it says they're supposed to verify the labels are legible. But I do like the fact when they are labeled, they're labeled in a nice, neat format. And I certainly, as an old inspector who's been doing this a long time, I appreciate when labels are labeled in ink and not in pencil, because that just shows the electrician knew what they were doing the first time they did it and didn't have to make corrections. Then as you look at the inside of the panel, we are supposed to look for overheat. We are supposed to look for loose connections. We are supposed to look for solid aluminum conductors. If we can't take this panel off, which again, as a commercial panel, it's A, heavier than a residential panel, and B, if I took this cover off with these 4 screws, I still have an inner cover that I would have to take off. That is the breaker lock panel, and I'm still not at the wires yet. And so we do not have to, per standard, take that off. But the key to look at as we go down the breakers is to note if we have anything that's overheated, I can use an infrared camera for. Now, one thing I want to talk about, when we have 3-phase. 3-phase means inside of this panel are 3 bus bars versus a 120 volt single phase, which is only one pair of bus bars or 2 bus bars. That 3rd bus bar in the middle creates the 3rd phase. And so when I see breakers like this one, which are 1, 3, and 5, they're accompanying all 3 bus bars, creating the 3rd phase. If I see a breaker like 8 and 10, that's the 240 volt single phase. And I think a great example here is you can see the difference between the width of a single phase and the width of a 3-phase. They're considered bigger. And so typically we use the 3-phase on things like package furnaces up on the roof, or heavy welding, or larger devices that take more regulated current than 240 a single phase would provide. In a panel like this, we want to make sure that all the openings are filled and not open. In this particular case, this entire side on the right side is completely full of breakers. The left side is not, but you'll see it's been filled with a filler, so that there's no way I'm going to be able to insert a tool or a finger inside of this panel and come in contact with the bus bar and the wires behind. So I've looked at this. I've annotated the size of the panel. I've noted what it is. If I had any malady on this, then written right here, or written right here, or written right here would be panel 1 or 2, whichever it is, because I'm labeled at panel 1 and 2 here, but I don't know if this is 1 and this is 2, or this is 1 and this is 2. That would be the only thing I would do is love to see that. So in my report, I would probably say labeled, but not completely, because I don't know who's who in the zoo. Then I would shut this panel up. Again, for sake of what we're doing, I'm leaving this open, but I've noted this is 225. So when I open up the 3rd panel here, I can look down here. 208, 120. We have not changed our voltage. 3-phase, 4-wire, 225, 225. So then that tells us that we are congruent across the system. Again, just like I did in this panel, I'm going to duplicate that here. I look at my labeling, I look at my breakers, I look at my knockouts. I would do an infrared if this was my inspection, and just to see if I've got any overheat on any of these. And then one other thing we want to talk about with doors. An electrics panel door must open greater than 90 degrees. If a panel cannot open 90 degrees, this one opens up to, probably 120 degrees. We can't safely work in this space. So if the panel, because there's some obstruction here, can't open up any farther than that, that would definitely want to be something we're going to make note of on a report. The panel, again, has to open up. Any door to an electric room has to open up greater than 90 degrees. Something to be mindful of. This is an electric room. So if I can't open up the door that even we're migrating into this room greater than 90 degrees, then we would have a problem. Because it's almost like when you were a child and you played that game Operation, We have to be able to maneuver into the electric space without coming in contact with the sides or with the clown's nose buzzes. In this case, the clown's nose is us, and we don't want to buzz. And so we want to, again, look at this. I've taken note of this. I've taken note of this. I've taken note of the label. And then I would close this up. Make sure I leave the condition in a safe manner, exactly how I found it. Even if it's not safe, when I found it, if there's something I can move away, I might move away. But I won't move all the merchandise they have, and then I will move on. The other thing that is very important in the electric inspection is there should be some form of placard indicating that this is the electric room. If this is in a space that's not wide open to the rest of the building. And so we would want to note if there's a mechanical door or a mechanical emblem or something else indicating this is the electric room. Throughout the rest of the electrical inspection, we're going to be looking at the distribution portion and then the receptacle switches for lighting, etc., as well as the electric distribution materials. We're looking for loose electric, uncapped electric, open junction boxes, broken outlets, broken outlet covers, missing switch plates, missing outlet plates, loose bare electric. If we saw anything that looked like solid conducting aluminum, which could be on some older outlets, then that would be something we want to note as well. One of the things we're not looking at is the low voltage. So by looking at some open electric, especially I'll show you some open electric in this building, it's for a pre-wire for a camera system. That would be what we classify as low voltage. So if that's hanging loose, that's something that we don't really need or should comment on unless your client specifically asked you to, and that you're well adapted and versed at looking at low voltage. As you go through the building, you're going to be testing outlets. You're going to be exercising switches. You'll be looking at those plates. You're going to test that sample of outlets. Now, going beyond the standards, because the standards say we do not have to move drop ceilings or suspended ceilings, or some people call them T-bar ceilings. We don't have to. But in my experience, going beyond the standards, when I get above these ceiling tiles, that's where most of the electric manipulation has happened. That's where most of the electric distribution exists. How do we get the light? How do we get the electric to the lighting? From the ceiling. How do we get the electric down the walls? From the ceiling. And so I've tried to take it upon myself to go up into the ceiling tiles. It's always a tough thing to do. It's always tough to figure out where you need to go. And so I go up in the ceiling tiles, again, above the standard, because I know I'm going to be rewarded with something that could be open or something that could be wrong as far as the electric goes. But what I want to look at up there is open junction boxes and then that blind bare electric connection. So let's take a look up at the tiles.